So, in our last class, we have worked on RC circuits, different nature of circuits. When current source is available, how to handle all that, I have given you an exposure. See, what has to happen is, you know the syllabus clearly. Monday, Tuesday, Sunday, you should focus on CUT syllabus. Wednesday, Thursday, Friday, you focus on Saturday mornings, focus on the VAT syllabus. This is how you should distribute your timings. Now, how to handle the circuits with multiple branches? I repeat, multiple branches. This is the area of our interest today, right? So very clearly, you can understand that what will they ask in such questions? If they ask about anything related to instantaneous values, practically that's a really very difficult situation that I am going to face here. No one will ask such situation. Generally, they will ask steady state conditions or t is equal to 0 conditions. For example, if they ask you at t is equal to 0, at t is equal to 0, at t is equal to 0, what will happen is that the capacitor becomes conductors. Then what will happen? 10 volt, 2 ohm, 10 volt, 2 ohm, okay, 3 ohm, 4 ohm parallel. Some x, okay, 12 by 20 volt, 6 ohm. You know how to find current in this circuit. What is the expression for current in this circuit? 10 into 6 plus 20 into 2 by 6 plus 2 times 12 by 7 plus 2 into 6 by 2 plus 6. 12 by 8. 3 by 2. This gives you current. Yes, sir. By any chance, can you quickly give me value of this? 60 plus 40, 100 by 8. 24 plus 21, 45 by 14. Okay. There now we are good numbers. Okay. 20 by 9 into 8 into 14. What best I can do is 7, 4. Okay. Right. That's what I have written. 12 by 7 ohms. Overall, what is the current? 35 by. Now you know potential drop across the resistor. Now you know the potential drop across these 2 points. That's all. So nothing interested in this. Okay. Once charging, once a steady state is reached, then what happens? Once a steady state is reached, So what is happening over here? The above circuit works differently. The below circuit works differently. How the way above circuit works differently? Forget about capacitor's path. I am assuming that the current is I1 here, and I am assuming that the current is I2 here. By the way, I1 is a very simple task, 10 by 5, 2 amps. I2 is 20 by 10, 2 amps. Right. Now, you know, above circuit behaves as 6 volts. Substitution theorem. Below circuit behaves as 8 volts, 3 microfarad, 6 microfarad. That is the equivalent circuit at steady state. So how many have understood this? Raise your hands. How many did not follow this? Raise your hands. Shreyas, what is your doubt? Be loud. See, steady state, just remove capacitor. So across 3 ohm, the current is 2 amps, 6 volts is the drop consistent across BG. And CF consistently, the drop is 8 volts. That's what I have written. I replaced that part with the batteries because that is a consistent drop, steady drop. So this is B, this is G, this is O, this is F. I'm still asking you again, you have any doubt in this? Boys and girls, I'm asking again, are you sure? అడుగుతున్నా కదా పైసా ఎందుకు రావట్లా ఇప్పటికే 3 times అడిగా ఐఎమ్ డూయింగ్ దిస్ అందుకే రికార్డ్స్ చేస్తా ప్రూఫ్ కూడా ఉంటుంది వెరీ క్లియర్ నో నెట్ ఈఎంఎఫ్ ఈజ్ 2 volts and equivalent capacity is 6 3 అంటే 2. So 2 microfarad equivalent capacity, 2 volts equivalent EMF, because they are driving currents in the same sense. So what is the charge? So therefore the charge here is Q 4 micro coulomb. So therefore clearly plus minus. So therefore that what do you want? A drop across VO minus VP is Q by C. 4 by 3 volt. VG minus VF is charge is the same, 4 microfarad, 4 microcoulomb by 6 microfarad, 2 by 3. Any doubts? Any doubts? Any student in this class who did not follow this? వాడు ఎక్కడ ఏ పాయింట్ వాడు సింపుల్ అబ్బా. హ్యావ్ యూ అండర్స్టాండ్ దిస్ సర్క్యూట్? ఫర్ మీ in my world this is the only circuit. When you are facing this circuit, they are driving currents in the same sense. So in that case, how to calculate net EMF difference? Minus plus. If that is the order, I would have considered it as sum of both EMF. It is not like that. Difference, equivalent capacity, equivalent voltage, charge transferred. Sir, I don't like this method. Good. Assume Q charge is transferred. minus 8 volts plus Q by 3 plus 6 volts plus Q by 6 is equal to 0. Apply loop rule. You will get the same condition as Q is equal to 4 micro. So at T is equal to 0, at T tends to infinite. Boys and girls, any doubt in this question? Ekraditya, any doubt? Right. Here is your next circuit. For the circuit shown, in the figure, what I want is current from the battery immediately after closing the switch, and in steady state battery current, and in steady state potential drop across the capacitors in steady state. Current through battery at T is equal to 0. Current through the battery at T is equal to 0. నేను కొంచెం కూల్గానే చెప్తున్నాను. అసలు నేను ఇంకా పాత్ ఫైండర్ దాకా ఎక్స్ప్రెస్ చేయాలి. ఈసారి టీచింగ్ స్టైల్ మార్చుకొని ఎలిమెంటరీయే చెప్తున్నాను. ఇంటి దగ్గర ఫిజిక్స్ చేయాల వర్క్, మీరు నష్టం మీరే పోతారు. 43 నచ్చలా. ఇంకా నేను 2-3 సార్లు వస్తే నువ్వు మెరిట్ అయిన స్టూడెంట్ ఇందులో తీసుకోగలడేస్తాను. నీకు ఆ నిహాలు గడికి తేడా లేదనుకుంటా. పులుగు తగులుతున్నారు, తగలుతున్నా. దమ్ము ఉంటే నెక్స్ట్ వీక్ 55-56 తెచ్చుకొని చూపించు. నాట్ ఎట్ ద ఎక్స్పెన్స్ ఆఫ్ అదర్స్. నేను కఠినంగా ఉండక తప్పదన్నా. నీకు మెడికేషన్ ఇచ్చేటప్పుడు ఆరెంజ్ ఫ్లేవర్, యాపిల్ ఫ్లేవర్ మందులు ఉండవు. మందులు కఠినంగానే ఉంటాయి, చేదుగానే ఉంటాయి. అసలు T ఈజ్ ఈక్వల్ టు 0 దగ్గర ఏం జరుగుతుందో నాకు చెప్పాలండి. పాత్ ఏమవుతుంది? డింగ్ 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 పాత్. ఎనీ డౌట్స్? అదే నీకు అర్థమైంది కదా? చెప్పు, ఎందుకు పాత అట్టది ఉంది? మళ్ళీ చెప్పు. అవును, తీసుకో. మార్కులు ఎగ్జామ్లో మాత్రం రావుగా. 20s 17s అవేగా. ఒక సబ్జెక్టే మనం చేయగలిగేది. డౌట్స్? So therefore, initially current at T is equal to 0 is simply I is equal to E by R1. Yes. Right. At a steady state, current through battery is at a steady state. Last current through battery at steady state E by what is the drop across R3? The potential drop across R3 is E by R1 plus R3 times. Chapra. R3. That is the current into కట్టే రాశానా ఒకసారి చెప్పండి. రైట్. Any doubts? What is the charge across C2? What is the charge across C2? Niharika Chapra. C2 into VR3. Correct. Q is equal to C. Why? Because R2 no current flows. Because current through R2 is 0 at steady state. What is the charge across C1? What is the charge across C1? C1 VR3. That's all. Okay. Next, I'm just giving you a situation like this. Here you have graphs given, and the graphs given. Adjacent figure shows discharging graphs of two capacitors having same initial charges. They are having same initial charges. Then what can we conclude? See, there are two capacitors having same initial charge, and here same initial potential difference across the capacitors and same charge. So obviously this will lead to what? Clearly C1 is equal to C2. Same initial potential difference and same initial charge. So where do the difference lies? No, what is happening over here? C1 is equal to C2. But the graph says there are two different graphs. How come this happens? The capacitance are same, but still why the graphs are two different connected to? Yes. So R1 is not equal to R2. And I told you lot of times. I told you in my last class also. I told you in my last review వచ్చింది. Your voice is cute and actually చెప్పాను హ్యాండ్ రైటింగ్ బాగాలేదని. My voice is cute, right from my childhood. I told in my last class, after one time constant, what is going to be the charge on the capacitor? See, for example, you set the same potential, same initial charge, so 0.37 times. Wrong. 0.37 times initial charge by E. When will it happens? Q naught by E, exactly after one time constant. So from the graph, you can see that this is the time constant for C1 and this is the time constant for C2. Very clearly, tau 2 is less than tau 1. What is a tau? RC. R2 C2 is less than R1 C1. You said C1 is equal to C2. So therefore, R2 is less than R1. So therefore, what are the conclusions that I can draw from this graph is this. This is how you should draw the conclusions. Suppose if their starting points are different, I cannot conclude anything on exclusively on this part. Because certain conditions are favorable for me, I have done some conclusions here. Any doubt in this question, please try to ask me. And now you should understand one point. More high is RC, more away from y-axis. More high is RC, more time it will take to come to zero. Any doubts? Any doubts? Yesterday, అరే నువ్వు నోట్స్ అడిగావు నాకు గుర్తుంది నువ్వేనా అడిగింది పెడతాను కొంచెం ఇంక్ పెడితే ఉపయోగం కదా See, when we are discussing this part, Mahalasmi, that time your focus is not there. So every term what I am uttering is important. Don't take choice from your side. I కూడా అంతే వస్తుంది ఈవెన్ డిశ్చార్జ్ లో ఐ కూడా ఐ అండ్ అరే discharge graphs, what are the formulas? Tell me. I is equal to I naught e to the power of minus t by tau. Q is equal to Q naught e to the power of minus t by tau. In this case, I naught by E. In that case, Q naught by E. Both are discharge current. Clear? May I close this concept? ఎట్లా చెప్తావు అది ఓకే అంటే ఫర్ ఎగ్జాంపుల్ వాట్ ఈజ్ ఈ సజెస్టింగ్ ఇస్ ఇమాజిన్ this is one discharge graph. What do you conclude in this graph? Now here try to please understand which one RC is high. Red one or black one? Hmm? Such a graph is not possible. So therefore, so you don't work on such graphs. What is the other possibility? No, my point is very clear here. See, please try to understand why not. Why it won't intercept? They have different initial charges. This one is having different initial charges. No, I didn't took same. No, I took something somewhere below only here. I took it from here. Hmm? Hmm. నేను అదే చెప్పట్లేదు నాన్న. దీనిది R1C1, దీనిది R2C2. గ్రాఫ్స్ అసలు ఇంటర్సెప్ట్ అవ్వవా? Different capacitor, different resistance. Is it possible or not? Maybe possible. So that is the reason such areas I will not work. I will not take any decision. That was so 90% of our cases, they will give us about information related to the initial status. Maybe initially they are at the same starting points. 90%. నేను ఏది ఏమైనా చేయగలుగుతామా అని అడుగుతున్నా. No, what can that be taken is that you must have some idea about. Now, for example, before this intercept, for example, before this intercept, if it falls down, before that intercept, if it falls down to 37%, then we can do some comment. If it happens thereafter, bit complicated situation, very difficult to post, well, purely mathematical oriented. Got the point? Right. But even then, work on initial slopes. What is initial slope? For example, what is that you are plotting is, suppose you are plotting V is equal to V naught e to the power of minus t by tau. dV by dt is V naught by tau e to the power of minus t by tau. dV by dt is the slope. Yet t is equal to 0, this is minus V naught by tau. It depends on three factors. Minus V naught by RC. So you need to have three different informations. Which means if you are plotting a graph, V versus this is the slope. You are finding this angle, say for example theta. So tan theta is modulus of dV by dt at t is equal to 0, which is nothing but V naught by RC. Suppose if they are same V naught, best what I can give you about RC, not CLO, not RL. You do one more round of differentiation also, I cannot do anything. Okay. Suppose if you give me C, for example, okay, I can comment something on that. Right. Next. Now you have situation, I want, see, this is an ideal battery. What happens? Nothing. Nothing. There are two different RC circuits. If suppose I have two R, 3C, I1. I2. That's all. So you will write I1 as simply as V by 2R e to the power of minus t by tau 1, where tau 1 is simply 2R times 3C, 6RC. I2 is V by R T2. Tau 2 RC. That's all. Any doubts? Any doubts? Boys and girls, any doubts? Total charge. Why? I1 plus I2, correct. But remember, all this is true when the line must not have any resistance. The entire line must not have any resistance. Only then it is true. Any doubt on this? Please ask me. Any doubt on this? Tasya, any doubt? Sure. Next. Any doubt? Sure. The next part. This is completely a different model. Now, in this case, if I am taking A as a node, okay. Taking A as a node, next. అయితే బాగా కోపం తెప్పించే మాటలు మాట్లాడుతాను. క్యూ బై C1 దేనికి వస్తుంది యూనిట్స్? దీనికి ఏమొస్తుంది ఇప్పుడు? కరెంట్. నేను నోడ్ ఎప్పుడైనా వేసుకోవచ్చు. కరెంట్కి ఏది యాడ్ చేసావు తెలుసా? పొటెన్షియల్ యాడ్ చేసావు. చెప్పాలి అంటే యూ నీడ్ టు నో హౌ టు అప్లై నోడల్ మెథడ్ ఇన్ సచ్ సిచ్యువేషన్స్. సో ఐ కాంట్ అప్లై. No, I want, this is current. So how to apply? First of all, CV is charge, of course. C dV by dt is current. So therefore, here you should apply C1 d by dt of VA minus, I think X is equal to 0. చేసుకోవచ్చు. నోడ్ ఎట్ట వేస్తావో తెలియాలి కదా నీకు. నోడ్ ఎట్ అన్ ఇన్స్టెంట్ ఎట్ట వేస్తారో తెలియాలి కదా. మనం మామూలుగా అయితే నేను ఇప్పుడు ఏం చేస్తాము, like this is taken as one loop, this is taken as another loop. Likewise, you can work, no issues. Your unknowns are two, I1 and I2. You require two equations. So therefore, VA plus R1 C1 dVA by dt, right, is equal to R1 C1 dx by dt. Equation 1. X is also changing. Why X is changing? Even though it is connected to battery positive terminal. Why X is changing? X means potential at that point is changing even though it is connected, because very smaller term there and the current passing through that smaller term will change, and hence the drop across X and O changes. That is the reason. That is the reason why I call this as equation 1. It all depends on R1 C1. Suppose if R1 C1 is same as R2 C2, there is no issue. So similarly, you can write VB plus R2 C2 D dVB by dt is equal to R2 C2 dx by dt. See, this will become easy only when R1 C1 is equal to R2 C2. Otherwise, this is a complicated. So therefore, usually in most of the occasions, they will give you that condition only. Otherwise, explore from hereafter. Unknowns are X, VA, VB. Unknowns. You require one more equation and then you will solve it. No issues. So what if R1 C1, if R1 C1 is equal to R2 C2 is some tau, say for example, only then I see comfort in that. Then what happens? In that case, VA minus VB is minus tau times, right? RHS is same, not so I am equating LHS. This is minus tau times d by dt of VA minus VB. So t times VA minus VB by VA minus VB is tau. Any doubt? What is VA minus VB initially? Just after closing switch. What happens? VA minus VB is 0. Nothing flows. So therefore, log E constant. That's what I am telling. That is the situation. That's the problem in this. So therefore, a very clear information is required for us to approach such problems. For example, if that information is not given for us proper, what I will do normally is I will take this as one loop, this as another loop, this as another loop. I'll get three questions. I will obtain the expressions for I1 and I2. Thereafter, I will proceed with the problem. But don't ask VA minus VB in such situation. It's a very complicated. Even though I have given these terminology, you are finding that there is something, a missing term here. Am I right or not? Am I right or not? Now, for example, what happens initially across AB? Any idea? Just t is equal to 0. What happens? Put t is equal to 0. Hmm. What is happening at t is equal to 0? If you don't understand, if you don't assume that some constant, you cannot do at all. Because VA log E 0 is not defined. Log E 0 is not defined. So definitely it should be some value. So such a problems also you will face. But 99.9% you will never face such situation. Okay. Next. Try this question. So I have accommodated a lot of contents here. Right. So hope you are doing this. In the given figure, initially all the switches are open and the capacitor has a charge Q. At t is equal to 0, switch S0 is closed. So what will happen? It follows the capacitor path, which means with S2, S1 closed, this is the only path available, right? Along with S1 or S2 or both, the value of current I1 and I2 at t is equal to 0 are shown in figure. Okay, they are shown I2 here, I1 here. Or wherever used 1 ohm. The S0 and S1 both are closed and Q is equal to 1 microcoulomb. So the drop here is 1 volt. What do you want? I1. See, initially, we'll take up cases. Switch S0 is closed along with S1 or S2 or both. I am assuming S0 and S2 closed. కాదు కాదు. S0 is closed along with S1 or S2 or both. సతీష్ చెప్పు సతీష్ చెప్ప వస్తారు. ఇప్పుడే మాట్లాడే నేను మన ప్రసన్నతో. నేనేమంటే 9:45 నుంచి మొబిలైజేషన్ స్టార్ట్ చేస్తే 10కి షార్ప్ గా మనం పెట్టుకోవచ్చాము కదా. అవును, మన బజాజ్ పిల్లలే మీ క్యాంపస్ దగ్గరకు వస్తారు. అది మీ ముందు మీ ముందర ఖాళీ ఉంది కదా, అక్కడ చేస్తారంటే మన దగ్గర ఇక్కడ స్పేస్ ఉండదు కదా బజాజ్ లో. మీ ముందర సరిపోతాయా? ఒకసారి కౌంట్ కనుక్కో, ఎంతమంది పిల్లలు ఉన్నారు ఏమిటి అనేది కనుక్కో. అబ్బో, మరి అప్పుడు ఆయన బజాజ్ ఎన్జి ఐసి కలిపేను కదా చెప్పింది. ఉంటారు జూనియర్స్, ఇన్కమింగ్ జూనియర్స్ 70+, 80 మెంబర్స్ వాళ్ళు ఉంటారు. 80 మెంబర్స్ 160 దాకా ఉంటారు. 160 మెంబర్స్ ఉంటారు కరెక్ట్ గా. మరి ఎలా? మరి నిన్న మాట్లాడుకుంటే ఇప్పుడు మాట్లాడే ఉపయోగం ఉంది. నిన్న చెప్పాలి కదా నువ్వు అప్పుడు. మరి నాకైతే ఐడియా ఉండదు. నేనేంటంటే మీ దగ్గర ఆ స్పేస్ కొంత ముందర ఖాళీ ఉంటది కాబట్టి అక్కడ మేనేజ్ చేయ. రైట్ 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 నువ్వు ఒకసారి ప్రసన్నత కోఆర్డినేట్ చేసుకో ఈ విషయం. నేను ఇప్పుడే ప్రసన్నకి ఇన్స్ట్రక్షన్స్ ఇచ్చొచ్చా. అవును అవును అవును, అంతే అంతే అంతే. అవును అదే బెస్ట్. అదే బెస్ట్. ఓకే, ప్రాబ్లం లేదు. రైట్ రైట్. ఓకే, అంతే రైట్. ఇవాళ చిన్న సర్వాణి ఉంది మనకి, సెలబ్రేషన్. కంట డిస్టర్బెన్స్ ఉంటుంది నాకు. నేను ఈ ప్రాబ్లంతో ఆపుతాను, మీరు చదువుకుంటుండ్రు. ఏదో చెప్తున్నారు చెప్పండి. ఇఫ్ ద S0 and S1 are closed, S0 and S1 are closed. Okay, right. So what will happen in that part? Nothing. Okay. The battery is charged. It is not uncharged battery. Battery is charged. Sorry, the capacitor is charged. So therefore, what happens is, that's all. That is the only option what we have. S2 is not closed, or 2 volts, or at that instant drop is 1 volt, plus minus, right? So now what will happen? Yes, it goes. Maybe the current splits as I1, I2, and again what ఇచ్చేసాడుగా, ఇది I1, ఇది I2, I1 minus I2, I1. 2 unknowns, 2 loops, done. You got the answer for this? Right. That is also okay, fine, no issues.